Hi, this is Team PacVN and here is our planning strategy and research algorithms we implemented in this Pacman capture the flag assignment. In this video, we are going to present about two planning algorithms, the heuristic search algorithms and the Monte Carlo tree search. This is our first offensive agent using A-star heuristic search algorithms, and the following is the strategy flowchart. When a game starts, offensive agent uses A-star heuristic to find the shortest path to the center point of the map. As soon as agent reaches the center point, it starts sensing around. If there's a ghost inside, it would try penetrating by walking along the border. When it's clear to go, agent plans the shortest path to the nearest food. While capturing the food, agent always sends the enemy ghost and retreat home via the shortest path when it's threatened. Once agent arrives at the home zone, it would keep walking along the border and find another chance to penetrate the enemy territory again. In another scenario, when agent senses no threats around, it would attempt to capture the food as much as it can until being chased home by the enemy. In the following, we will discuss about the defensive agent using A-star heuristic search. For the defensive agent, we define an optimal defensive zone and let our agent patrol within that area. During patrolling in its defending zone, whenever agent can sense any of its defending food being captured, agent immediately sets the shortest path to that food. While agent is moving to that location, if agent finds enemy on the way, agent will chase after and then try to capture the enemy. After agent captures the enemy, it returns to the defensive zone, and from here, agent starts patrolling in the defensive zone as usual. Next, we will discuss about the Monte Carlo tree search offensive agent. Inherits from the strategy from the heuristic agent, Monte Carlo tree search agent will try to get the best move based on the game state and its simulated scenarios. Similar to the heuristic agent, when the game starts, Monte Carlo tree search agent will find the shortest way to the border point. Right after the offensive agent reaches the border, it implements the Monte Carlo tree search to find opportunity to penetrate into opponent's territory, using the feature vectors and the weight vector design for the penetration process. After crossing the border, offensive agent uses another feature vector and weight vector design for capturing food process, and will start collecting the nearest food. After eating a certain number of food, agent returns home. As if agent captured a capsule, agent is no longer afraid of ghosts and can continue what it was doing. When in the enemy territory, agent will try to avoid encountering ghosts. If agent senses dangers around, agent will immediately retreat, using the feature vector and wave vector design for the retreat process. If there's a ghost blocking on the other side, offensive agent will not take any further step into that area, but try to find another path to cross the border and look for a chance to penetrate again. With epsilon value 5%, the offensive agent is inclined to explore but not exploit the best values. In this assignment, we have encountered some limitations. For the heuristic search agent, the agent cannot adapt to the changing of the game state. The target selection logic becomes more complex when having more conditions. And for the Monte Carlo tree search agent, sometimes the agent got trapped in the dead end, and sometimes some arbitrary move is not optimal at all. For example, in this scenario, agent is trapped in a dead end and blocked either ways by two enemy ghosts. There are a few improvements we want to implement to our heuristic search agents, such as capturing enemies' capsule or intercommunication between two agents. For the Monte Carlo tree search offensive agent, we want our agent to collect more food when there's no threats around. We want to optimize the benefit of the capsules. We can improve the retreat strategy to avoid being besieged by ghosts, ready to commit suicide if necessary. We can add more features to avoid dangerous dead ends, consequently being killed by ghosts. We can combine the Monte Carlo tree search with the key learning technique to improve the results. Thank you for your attention.